Welcome back. We're back to the second section of Chapter 2. We're going to talk a bit more about linear functions. Remember, functions are graphs or equations actually, where each x is assigned a unique value of y. So here we go. Let me move this recorder out of the way a little bit so I can see everything. So here are some of the things we're going to talk about for a few minutes. And let's get over here. Okay, there we go. First of all, graphing using intercepts. Boy, this really gets easy. So hope you enjoy this part of it. So first of all, if you have an equation of this form right here, ax plus by equals c, where a, b, and c are just regular numbers, and a and b are not both 0. One of them could be, but not both of them. Otherwise, we don't have an equation at all, really. If you make a and b both 0, you have 0 equals whatever c is. That's sort of strange. Not good at all. Anyway, they're called linear equations because they're lines, and two variables because you got two variables, x and y. First of all, locating the intercepts. Where are the intercepts and what are the intercepts? Intercepts are the same thing as what you see in the sky when you see a jet go overhead and there's a trail behind it. Sometimes those trails intercept each other or intersect each other. Well, this is the same thing. Where does a graph go across the x-axis or go across the y-axis? So first of all, if you want the x-intercept, now don't get this backwards. If you want the x-intercept, set y equal to 0. X is going to have a different value typically, but the y is 0. Put the 0 in for y, solve for x, and there's your x-intercept. If you want the y-intercept, do the opposite. Set the x equals 0 and solve for the y. That gives you 2 points. Connect them with a straight line. Use a straight edge of some kind, even a book, and there you've got your line, as long as you've got a linear equation. So here's an example, 3x plus 2y equals 6. So how would we do this one? First of all, let's suppose we get the x-intercept first. So that means we're going to set y equals 0. So if y is 0, then we'll have 3x equals 6, x equals 2, and we've got one of the intercepts already, 2, 0. How about the y-intercept? Well, just about as easily. Set the x equal to 0. Now if you set the x equal to 0 over here, then this term will be 0, and we'll have 2y equals 6, y equals 3, and our second point is 0, 3 for the y-intercept. There are 2 points. All you have to do is graph those on the Cartesian coordinate system, put a straight edge between them, and draw your line. It's as easy as that, really. And intercepts are fantastic, if they exist. And there's what we just did. A little bit neater, perhaps, but don't be too critical, okay? The y-intercept, set the x equals 0, and there's your second point. There's your graph. Here are the 2 points that we found, there and there. And just put your book on that. Connect those, and you've got your graph of the straight line. Now, Here's a tip for you. If you go to mathbits.org, now this isn't exactly free, but very, very close to it. If you go to mathbits.org and take a look, I think it might be on the first page, or it might be a subsidiary page. They have graphs of all kinds, even graphs like this, where maybe you want these squares to be real small or real big, whatever you want. They've got all kinds of graphs. All you have to do is download it for nothing and print it out wherever you've got a printer. And you've got graph paper. Easy as that. In fact, what you could do, excuse me, you could print out one, and if you like it, take it to a copier, print out maybe 50 of them, and then pass them out to a few friends too. So, sort of an easy way to make friends, right? Who knows who you'll run into if you offer something free. Now, we can verify our work. Check for x equals 1. Put x equals 1 into the linear equation. The y-coordinate will be 1.5. Now, we get the slope, something a little bit more interesting. So the slope of the line through the distinct points. The slope usually is represented by the letter m. And you find that, notice you've got 2 points. A set of ordered pairs here for the first point, a set of ordered pairs here for the second point. Just take those 4 numbers like this. Y sub 2, that's the y-coordinate for the second point, minus the y-coordinate for the first one. On the bottom. Now remember, you have to make sure the y's are on the top and the x's are on the bottom. The other thing is you're going to subtract in the same way. So notice that this coordinate and this coordinate come from the same point. So that's a good double check for you. X sub 2 minus x sub 1. Same order, and you're in good shape. Do not do this. It's not y2 minus y1 over x1 minus x2. No, 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 no. Make sure you're subtracting in the same order. These two will be from the same point. These two will be from the same point. The second y-coordinate minus the first. Same thing with the x's. It's called the rise over the run because the y values mean how far are we going up or down when we go from one point to the other. The run is how far we're going left or right when we go from the first point to the second point. The only thing you have to be concerned about, and this would make total sense, is that the x sub 2 minus x sub 1 can't be 0. Another way of putting that is x sub 2 and x sub 1, the two x coordinates, can't be the same. Otherwise, you won't have any slope at all, because most of you know you can't do that division. 6 divided by 0, you can't divide by 0. That's why. So here's a picture. Here's your first point. And the ones we use here don't mean that the x is 1 and y is 1. It just means it represents the first x coordinate and the first y coordinate. This second x coordinate and the second y coordinate. That's all the x and the y subscripts represent. That way you can tell that this one goes with this in one ordered pair. And these two go together in an ordered pair because of the subscripts. Remember, subscripts are the ones that are underneath, somewhat underneath, the main letter, the x or the y. Next, let's go to a particular example. We want the slope of the line that goes through those 2 points. So let's call this point 1, and let's call this one point 2. Then this will be x sub 1, y sub 1, and the other will be x sub 2, y sub 2. Now how do we find the slope? Remember I said the slope is usually represented by the small letter m. We're going to subtract the y's on the top, and we're going to subtract the second one minus the first one. So it's a -2 minus, and over here we've got a -3, oops, -1. Now what did I just do? I messed it up, right? The y's are supposed to go on the top. So here's where you might help yourself from making a mistake. You're subtracting on the top and on the bottom. So you could write it in like this, then focus on what the actual numbers are. Now on the top are the y values. So here's the second one, that's 4. And of course there's only one y value left here, -1. Now x is on the bottom. Start with number 2, that's -2. And of course there's only one number left, -3. And then very carefully, because there are a lot of negative numbers here that could mess you up. First of all, rewrite it. This will be 4 plus 1 on the top. Don't bother trying to do it in your head unless you're really good at this. On the bottom, it's -2 plus 3. Now it makes it easy. On the top, you have a 5. On the bottom, you have a 1. And we'll just simplify this 1. So the slope of a straight line that crosses those 2 points is a 5. That means it's very steep. A slope of 1 is the same as 45 degrees, just for your information. That can be handy. A slope of 0 means 0 degrees. It's totally flat. We'll get back to that. So here are the coordinates as we just put them in. And the result, the slope of the line is 5. And you can see that 2 things about this. First of all, because it's a positive 5, when you go from this point to this point, you're going upward from one point to the other. The other thing is, it's rather steep too. It's no 45 degrees, it's much steeper than that. It's between 45 and 90 somewhere. But we won't be working with trigonometry. Relax. Now, very important. One of those formulas you really want to remember. This is a slope-intercept form. Why is it called that? Because right in front of you, you'll have the slope and you'll have the y-intercept. In this particular one, all you have to do is look in front of the x. There's the slope and the y-intercept. What does that mean? It means since this is a positive 2, it's going up. Since the 2 is going up rather steeply, anything above 1 is a little bit on the steep side. And the second point, or second number, what does that mean? This is where it crosses the y-axis. So if we've got our x and y axes like this, it's going to cross down here somewhere. How about the second one? Take a look at this one now. What does it say? Well, it says the slope is 1/2. So the slope is not going to be as steep as the other one was. And it's going to cross at y equals 2. So it's going to cross up here somewhere. So my quick graph was a little bit off. I'd have to yank it upward 2 units to get it right. So if you have it in slope-intercept form, if you've got it like this, how can you graph it real easily? Well, this is, I don't know if it's a piece of cake, but maybe it's a cookie or a pie even. First of all, plot the point containing the y-intercept. In other words, take this. This tells you where it's going to cross the y-axis. Grab that point. Graph it. Second, you need another point if you're going to graph a straight line. We're going to use a slope. Remember, the slope is rise over the run. Slope, rise, that's the y values, over the run. How are the y values changing while the x values are changing? Once you got those 2 points, and we'll get to that example in just a moment, use a straight edge to draw a straight line, and don't do one like this. I don't have a straight edge I can use. Don't draw a line like that. Well, this one isn't too bad. But if you use a straight edge, it looks much nicer, really. If you don't have a ruler with you, that's fine. You can use a book. You can even use another pencil, usually, for a straight edge. Lots of possibilities. And draw the arrowheads at the ends of that line. So let's get to an example here and see how this really works. Here's our equation in slope-intercept form. That means the slope is here, that's m, and the y-intercept is here, that's b. So how do we graph it? I'm going to just do a rough one. I didn't go to mathbits.org yet. First of all, we go to the y-intercept. The y-intercept is going to be 2 units up here, so there's 1 point. How do I get a second point? Well, the slope is 2 over 3, so that's the rise over the run. So remember, these are x values down here and y values here. So start from the point you already have, go plus 3 because you got 3 in the denominator, and up to, you got another point. You want another one? Over 3, up 2. And draw in your straight line with a nice straight edge, and you got your line. Another option, by the way, now don't tell anyone this, but here's a slope. So we use the 2 and the 3 to get these other points. Here's a sneaky thing. Now remember, don't tell anyone. You could do the same thing by using -2 over -3. Same number, right? Positive divided by positive is a positive. Negative divided by negative, positive. So what you can do down here is start with that y-intercept. Go at -3 in the x direction, -2 in the y direction. You've got another point. Do it again. You get another point. Draw that straight line. It's the same thing. Pretty neat. So you have your options. Another possibility, for example, let's suppose you've got a particular slope, and let's suppose it's -3/5. When you're doing this to figure out what those other points are, you have 2 choices. You could make this -3/5, or you could make a 3/5 because they're all -3/5. And this helps you find more points. Just some options for you. So let's take a look. Plot the point containing the y-intercept on the y-axis. And the y-intercept is 0, 2. The rise over the run, there's the 2/3. Use this 3 and this 2 to get to the second point, 3, 4. Use a good straight edge now. No sloppy stuff. I don't have a straight edge here, or I would use it. Make sure it's nice and crisp. And put the arrows on both ends, because those lines don't stop anywhere, they continue, and the arrows indicate that it does continue. And there's our graph. Here's the y-intercept and the rise over the run 2/3, going from one point to the next point, gives us additional points from which we can line up our straight edge and draw our line. So how about this one? Graph that one using the slope and y-intercept. We've got a little bit of a catch here. It's not in slope-intercept form. Oh no. Wait. It's not that bad. You could put it in slope-intercept form. You want it looking like this. That means you need one y on the left side. Well, y is on the left side, but minus the 2x is there. So we'll just subtract 2x from both sides. Y equals minus 2x. Now notice there's no y-intercept. Well, if there isn't anything out here, then it must be a 0. So all of a sudden you've got it. The slope is -2. The y-intercept is a 0. So you want to graph it. The y-intercept is right here on the y-axis. -2. We'll write -2 as a fraction because we want slope. Oops, -2. I can write it as -2/1, or maybe you want to write it as 2/-1. Either way is good. So start from the point you do already have in the middle here. Go -1x, +2y. -1x, +2y. Connect those with a straight line, and you've got your graph, which will be the graph of 2x plus y equals 0. It's that easy, really. Get a little bit of practice, you'll become a pro. Put it in slope-intercept form. Now here's a little bit of a different one. This one has 2x plus 5y. I see I made a mistake, but it's working well. On slide 12, I want to make a note here. Slide 12, I'm going to fix this. But that actually works out really well. So here's our equation. Solve it for y. Get the 2x out of the way, subtract the 2x. We end up with 5y equals minus 2x. That's good, but not good enough. We want in slope-intercept form. We want y equals whatever. So we'll divide both sides by 5 right here. And there's our slope-intercept form. Don't see the intercept? Just like I said before, it must be a 0 then. So here's the y-intercept. Here's the slope. So we can graph this one. There's the y-intercept. The slope is -2/5. So I'll start from here, go over 5, down 2, over 5, down 2. Connect the dots with a nice straight line, a little bit better than mine, and you've got your line. Put it in slope-intercept form, start with the y-intercept, play with the slope to get some extra points, and you're in business. Okay. You can follow this, I hope. We've got another one that goes through the origin because the y-intercept is 0. There's the rise over the run, and so on. Now, here's a new topic within this topic, subtopic I guess you would call it, horizontal and vertical lines. Now this, Although it might sound trivial, I find it most helpful to actually commit this to memory. If you've got an equation like this, it's a horizontal line. And also not only horizontal, y equals b, horizontal line, and third, the big three, y equals some number, is a horizontal line, has slope 0. I would suggest that you learn this triplet well enough so that if you see slope of 0, you think, oh, that's a horizontal line. And the equation for that is y equals some number. And it'll look like this. There's a horizontal line, slope is 0, the big three. Well, one of the big threes, because we've also got the possibility of a vertical line. And a vertical line has an equation that's sort of the opposite of the first one. This one looks like this. The x-intercept is a, and slope, because we need three things, x equals, vertical line, slope undefined. We mentioned that a little bit earlier, that if you were trying to find the slope of something that has x equals 7, for example, the x values are the same. So you, in finding the slope, would be dividing by 0, and you can't do that. So that's why the slope is undefined for x equals a type of equation, like that. And it's also, this is not a function. This one is a function, a very special function. It's a constant function because the value is always the same. Next, with that in mind, can you pause the video? I dare you to pause the video and graph that. If necessary, slip back, look at that again, so you can get y equals -4. Can you graph that real fast? You should, and you should also, once you do a little bit of memorization, you should automatically know what the slope is for that thing. The slope is 0, y equals -4, and what's the third thing? Okay, you got it? Slope is 0, y equals -4. You're in business. Now, remember what the equation actually says. It says this is how we put together the ordered pairs. This is the rule for making these ordered pairs. This particular rule says when you're making the ordered pairs, the y values have to be -4, period. End the story. So over here, when you're making a small table of x and y values, excuse me, all the y values are -4, period. So you can put -4s in, pick whatever x's you want to. All these y values are going to be -4. Very simple, but if you're not familiar with it, it could look weird, but it really isn't. It's very simple too. So there's your graph. Notice it's a horizontal line, slope equals 0, and it's y equals -4, also known as f of x equals -4. This version of it emphasizes the fact that it's a function, not just a graph, not just an equation. So if you did that one, sneak back here a second, if you're able to do this one, Can you do that one? Okay, if you've memorized that triplet I mentioned, x equals 2 should immediately say the slope is undefined and it's a vertical line. There is some beauty to memorizing just a little bit those two triplets about y equals something and x equals some number. Makes things very easy. On this one, this is the rule. It says all the x coordinates are going to be 2's. So over here where you've got your x's and your y's, all the x's are 2's. Pick anything you want for the y, because this says nothing about the y values for the y coordinates. There's your graph of x equals 2. And just a reminder, a vertical line does not represent a linear function because you've got a vertical line that has two different x values. Or, excuse me, two different y values for a particular x value. Every other line is a function. Every other line is a function. Not every other graph. Every other line is a function. Any line that's not a vertical line will be a linear function. So here we go. Graph that. Just two different versions of the same thing. Horizontal line. The y-intercept is b. So just take that. Say b is up here. If it's y equals that number, and this is your graph because it's horizontal. Very, very easy. If it's x equals, then it's going to be vertical, and it depends on where a is, to the right or to the left of the origin. Slope is not just something that has to do with graphs on a Cartesian coordinate system or a rectangular coordinate system. It's a ratio, really. That slope is a ratio of how the y values are changing compared to how the x values are changing. And those x and y values can be various things. For example, in your car, you have something that tells you miles per hour, depending on how fast you're going. That's a ratio. How many miles are you going for every hour you would go at that speed? This is the rate of change, and it can be lots of different things. Miles per hour is one. In fact, talking about cars, miles per gallon. That's an important thing. Most of you want more miles per gallon, right? Gets you to school and back a whole lot faster. Now we've got a picture here, and I'm going to let you interpret it a little bit. You can hit the pause. It says, find the slope of the line segment representing the women. And we're talking about from 1970 to 2010. And these are all women that are 20 to 24. That's not in the graph. Those are the only ones that are being graphed. What does the slope represent? We're going from 1970 to 2010. And we're talking about the women. So we're talking about the blue line, even though I'm using a red pen to point to the blue line. Ignore the men for the time being and find out what the slope is. Well, here's one point. That point is 1970 and 45. For the women, it's 1970, 65. And 2010, it's 21%. So you can interpret that. What does the slope represent? Well, what is the slope? If we look at the women, remember the slope, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So here's your first point. Here's your second point. So on the top, you're going to have the y values, so it'd be 21 minus 65. On the bottom, you'll have the x values, which are the years. So it'll be 2010 minus 1970. Subtract on the top, and what do we get? Negative 44. And on the bottom, we'll end up with 40, which means negative 11 tenths, or negative 1.1. Negative 1.1 what? Remember those examples I mentioned earlier? Miles per gallon, miles per hour. They have units usually. What are the units? Well, very simple. What did we subtract? Well, the numbers we subtracted on the top were percentages. And these were years in the bottom. So we've got percentage per year. And that's how that's changing. The percentage of women who were married at a particular age is decreasing because of that. It's going down. Where it'll go, who knows? Certainly can't go below 0. So there's our answer. And that's how you could describe it. The rate of change is negative 1.1% per year. And folks, these linear functions are the most useful for modeling data. Very important. Now, I do some editing for a certain PhD in statistics every once in a while, and every chance he gets when he's doing some statistics and creating a model, he's trying to make it a linear function. That is sort of the gold standard for modeling data. If you can make it into some kind of a linear function, you're way ahead of the game because there are more tools that you can use on linear functions than for any other kind of functions. By the way, before we leave, you got linear functions. What else do you have? Well, for one, you have quadratic functions. You have exponential functions. And there are quite a few others too. Those are probably the big three, I would say. Well, I think we're taking care of functions. We'll see you next in 7.3, and we'll talk a little bit more about graphing and functions. Till then, you take care of yourself. Bye-bye.